As promised, continuing the series of weekly contests 288. My name is Sanjay Dudeja. I'm working as SD4 at Adobe, and here comes the first question of the contest. Minimum number of operations to convert time. Here in this question, we are given two times, one the current time, other one the correct time. We have to identify the minimum number of operations needed to update your current time into your correct time. Both these times are given in 24 hours format. Also, in each operation, you can increase the current time by 1, 5, 15 or 60 minutes. What we need to identify, we need to count the minimum number of operations needed to convert the current time into correct time. So here they have provided us with an example, and the biggest hint that the question says is that you can increase the time by 1, 5, 15 and 60 minutes. Please keep a note of this point, and we'll be exploiting this point in the presentation where I'll be explaining this example as well as the algorithm to go about it. So let's quickly hop on to it. Minimum number of operations to convert time. Leetcode 2224. It's an easy level question on Leetcode, and I totally feel the same. Also, in case if you have ever doubt, feedback or suggestions, please feel free to ping me on the Telegram group of Coding Decoded or the Discord server. I'm looking forward to seeing messages from all of you. Now let's hop on to the same example that was specified in the question. We have the current time specified as 2:30 and the correct time specified as 4:35. The denominations that are given to us are as follows: 60, 15, 5 and 1, and all these denominations happen to be in minutes. So my first move would be to convert my current time into minute format. How can I do that? I will simply parse this string. I'll extract the first element, which is 2. I'll convert it into integer format. I'll multiply it with 60. I'll get 120. 120 plus 30 gives me 150, and the total minutes that the current time represents happens to be 150. So I'll create a helper method for it. Similarly, I'll cast this time into total minutes format. 4 into 60 gives you 240. 240 plus 35 gives you 275. So let's write it up. 275. Now what we should do, we should calculate the difference between the current time and the correct time, and this difference would come out to be as 125, and the denomination here would be equal to minutes. Now we have made this difference in sync with the denominations format that is given to us, which is again minutes. Now it's really simple. What we need to identify, we need to identify the minimum number of operations using these denominations that should be performed in order to achieve the total of 125. So what will I do? I'll obviously go from the maximum denomination that I have, which is 60. So I'll be using 62 times to reach 125. So let's consume 62 times, and the remaining sum that we are looking for gets updated to 5. 60 into 2 gives you 120. 125 minus 120 gives you 5. And the total number of operations that you have consumed happens to be 2, wherein you use 62 times. This can be easily calculated. If you divide 125 by 60, you'll get 2, and this is what I have written here. For the remaining part, it is again really simple. You can identify 125 modulus 60. It will give you 5. Let's proceed ahead. Next we see is 15. So can we achieve 5 using 15? You can't. So let's skip it. 5 by 15 gives you 0. 5 modulus 15 gives you 5. So we can't achieve 5 using 15. Let's proceed ahead. Next we see is 5. So what we should do? We should consume this 5, and let's divide 5 by 5. What do we get? We get 1. So let's add it to our total count of operations, which turns out to be 3. The remaining value turns out to be 0. 5 modulus 5 is 0, and we break our loop, since we have to achieve the total sum of 125. And the total operations that we did turns out to be 3, and this is our answer. To conclude it further, let's quickly walk through the coding section. Here I've created a helper method which will basically convert the timestamp into total number of minutes, and it is basically parsing the timestamp by colon. The first part will represent hours, the second part will represent minutes, and the total time that would come out to be hours into 60 plus minutes. Now let's get back to the main algorithm. I cast the current time into minutes format. I cast the correct time into minutes format. I identify the difference. I have created a count variable that will actually store the minimum number of operations needed, and I have created the denominations array. Also remember to keep this array in decreasing format because we want to consume the maximum denomination first. So I iterate over all the denominations that I have. I divide, I've checked whether the difference that I'm trying to achieve modulus denominations turns out to be 0. If it does, then I break out from the loop. Along with this, I increment the count by diff divided by denomination. Otherwise, I again do the same thing. Count gets updated to count plus diff by denomination, and with each iteration, I update my diff to diff modulus denomination. In the end, I simply return the count variable. So let's try this up. Accepted. Pretty simple and straightforward. The time complexity here is constant time, and the space is like also again constant space. We are not using anything extra. This brings me to the end of today's session. I hope you enjoyed it. If you did, please don't forget to like, share and subscribe to the channel. Thanks for viewing it. Have a great day ahead and stay tuned for more updates from Coding Decoded. I'm solving more questions of the contest.